This is lesson 6.3, logarithms and logarithmic functions. So the first thing is we're going to define the logarithm of y with base b as log, we put the little b down here, y. And it's true if b raised to the x equals y. So we can actually turn an exponential equation into a logarithm. All right, this is red log base b of y, and we take the base, raise it to the equals the of y. We call this logarithmic form and this exponential form. So we should be able to convert between the two. So we just said the exponent is the equal. So this is the exponent because that's what it was equal to. 2 to the 4 equals 16. And I kind of make like a spiral. 2 to the 4 equals 16. So then if I look at my spiral, 4 to the 0 equals 1. Make my spiral. 12 to the 1 equals 12. And make my spiral. 1/4 to the negative 1 equals 4. So you go ahead and try this one, pause, when you're ready to see an answer, hit play. So I got 6 to the 3rd equals 216. So now I should be able to rewrite the other way. I should be able to take it from exponential form to logarithmic form. So we know the exponent is going to equal, and this is base. So it's log base 5 of 25 equals 2. And if we go back and check, I made my spiral, 5 squared equals 25. So here we're going to have log base 10. And actually, we'll talk about this in a bit, but if I don't put a number here, the base is automatically 10. I could have just written log. So log base 10 equals, of 0.1 equals -1. And for this one, log base 8 of 4 equals the exponent 2/3. So you go ahead and try this one, pause, when you're ready to see the answer, hit play. All right, so I got log base 9 of 81 equals 2. We can evaluate logarithms because we know that 4 raised to something will equal 64. So 4 raised to something equals 64. We have to ask ourselves, what power gives us 64? And that's 4 to the 3rd. So log base 4 of 64 is 3. All right, 5 to what power gives me 0.2? And I'm going to write 0.2 as a fraction. That's actually 1/5. So how would 5 turn into 1/5? Well, it would move to the bottom because of a negative exponent. So that actually equals -1. Here, 1/5 to what power would equal 125. So first, the negative will bring it up to the top. So now 5 to what power is 125? 5 to the 3rd is 125. So there's really -3. And here, 36 to what power equals 6? So really, the square root of 36 is 6, which means the power is 1/2. So you go ahead and try this one, pause, when you're ready to see the answer, hit play. So 4 to what power is 256? 4 to the 4th power is 256. So like I mentioned earlier, the common logarithm is a logarithm with base 10. So you can put the 10 as the base, but again, if you don't put any number at all, it's assumed to be a base of 10. The natural logarithm has a base of e. So we can write it as log base e, but more frequently it's written as ln. All right, so log base e is actually ln. So we're going to evaluate these using a calculator, and we're going to round to 3 decimal places. So the first one is log 8. So our calculators have a button that says log. So log 8, enter. So we get 0.903. The next one is natural log 0.3. So our calculator also has a button for natural log. ln is down here, so ln 0.3, enter. We get negative 1.204. Log base 3 of 10 is a little trickier because we don't see when I hit log, I don't get to choose a base. So when I hit log here, they're assuming a base of 10. So there's 2 ways to go about this. If I hit alpha and y equals, it's going to give me some choices here. So I don't want fractions, I want functions. I'm going to go over to functions, and number 5 has log with a base. So I'm going to choose 5, and now I can select a base of 3 of 10, and I get 2.096. We're actually going to learn about expanding logs later on, but for now, I can tell you that what we could also do is take the of, do log 10, divided by, take the base, log 3, and I get the same answer. So if you don't want to have to go to alpha, find the log base problem, you could actually divide log 10 by log 3. So the of by the base. So you go ahead and try these 3. Pause. When you're ready to see the answer, hit play. All right, so for the natural log of 18, I got 2.890. For log of 2.7, I got 0.431. And for log base 6 of 92, I got 2.524. All right, so by the definition of a log, the log is the inverse of the exponential function. So these 2 functions undo each other, right? And if you recall from when we first learned about inverses, you get x back as the answer both times, right? So I could take log base b of x and turn that into the exponential form b raised to the x power, right? Those are the inverses of each other. So we're going to use this to help us graph logarithmic functions. Since the inverse is always a reflection in the line y equals x, and we change the x and y values, they get swapped, then what I can do is I could figure out the points for the inverse function, the exponential function, and then reverse them to graph for the log function. All right, so that's what we're going to do. To graph a logarithmic function, we're going to convert it to an exponential form, create that table of values, and then reverse it because the domain and range switch. This also means because all exponential functions had a horizontal asymptote, so here I want to graph log base 3 of x. So the exponential form is 3 raised to the x power. We always put in negative 2, negative 1, 0, 1, 2. We know anything to the 0 power is 1. 3 to the first is 3, so the negative 1 is 1/3. 3 squared is 9, so negative 2 is 1/9. And now for my log, we're going to swap. So my negative 2, negative 1, 0, 1, 2 will now go in my y column, and my 1/9, 1/3, 139 now go in my x column. So it is going to be a little tricky to graph some of these because they're very, very small numbers and they're very close together. So we have 1/9 negative 2, 1/3 negative 1, 1, 0. Then we have 3, 1, and 9, 2. So before, the asymptote would have been y equals 0. So now my asymptote is actually x equals 0. So I'm not going to cross this line here, and it's very hard to see when I go over it like that. So we're going to get real close, but never touch it here. All right, we're going to pretend that didn't really curve there, that it went straight down, but that's not going to make it any better right now. So I'm going to ignore it. All right, so that is the graph of log base 3 of x. All right, let's do another one together. So 1/2 raised to the x is going to be my exponential that I use. So I know anything to the 0 is 1. 1/2 raised to the 1 power is 1/2. If I flip it, that's 2. 1/2 squared is 1/4. If I flip it, that's 4. And now we are going to swap. So we're going to have 4, 2, 1, 1/2, 1/4, negative 2, negative 1, 0, 1, 2. So we have 4, negative 2, 2, negative 1, 1, 0, 1/2, 1, and 1/4, 2. Okay, and again, our asymptote would have been x equals 0. So you go ahead, try the last one, pause. When you're ready to see the answer, hit play. All right, so here is our graph of log base 2 of x. Once again, we had a asymptote or an asymptote of x equals 0. And that is section 6.3, logs and log functions.